Hello, this is Mr. Stansbury. I'm going to take you through the problems from the 19J assignment. All right. So here's number one. It says find dm over dt, which is basically the derivative of m with respect to t. Right. So here's m, and then t's our variable. So we're just going to take the derivative of this. All right. So that's just going to be 3. Again, remember the 3 goes out front. 3t subtract 1 from the power 3t squared minus, again, 2 times negative 3 is negative 6. Subtract 1 from that, and we have t, and then again, that's officially x to the 0, so 0 times anything gives us 0. Remember, the derivative of constant is 0. All right, so there's A. B, we're actually going to want to multiply that out first so that we can take the derivative. That seems to be the fastest way. So let's do 2t plus 1 times 2t plus 1. Again, you can FOIL it if you want. I like to do the stack method. So 1 times 1 is 1. 1 times 2t is 2t. 2t times 1 is, we can put the 0 in there to hold the place. 2t times 1 is 2t. And then 2t times 2t is 4t squared, right? And then that just gives us 4t squared plus 4t plus 1. Now again, that's not the derivative. That's just simplifying out, well, just multiplying the function out. So now we want to take the derivative, which is 2 times 4 is 8. Subtract 1 from the 2, and we get 8t to the first, or just 8t. And then this is 4t to the first. 1 times 4 is 4, and then you subtract the 1 from that, and you end up getting 0, so our derivative is just 8t plus 4. All right. Let's see. Let's try C. We've got this here, so we've got one thing. We've got the r down below, so let's move it up top. So we're going to have r squared minus 100. Since it's on the bottom and it's positive 1, we move it to the top and it turns into negative. So now we take the derivative, we get 2r, and then negative 1 times negative 1 is plus 100, and we subtract 1, so r to the negative second. And I'm fine if you just leave it like that. You could, again, rewrite it as 2r plus 100 over r squared. Either one of those is just fine. All right. And then D, this one here. Let's try this one out. Nothing to multiply out. That's h to the first. So 1 times 2 is 2. We'll just leave 2 pi. And then that's subtract 1, so it's just 2 pi. 2 times a quarter is a half. All right, subtract 1 from that, so h to the first. All right. So there's all of our answers for number 1. All right, number 4. We've got this equation for the height of a palm tree, where the height is in meters and t is the number of years after the tree was planted, and this equation only works when t is greater than or equal to 1. So it's only after 1 year. Okay, from an established potted juvenile tree. All right, so how high was the palm after 1 year? So this is just good old algebra. We're just going to plug in t. We're going to plug in 1 for the t, right? So we're going to just do 20 minus 18 over 1. So that's just 20 minus 18, which gives us 2. All right. Sorry, I don't know what the heck that is. Let's get rid of that. All right. So we've got 20 minus 18 is 2. Part B, find the height of the palm at t equals 2, t equals 3, t equals 5, 10, and 50. So we're basically just going to keep plugging. We'll plug 2 in for t, 3 in for t, so forth and so on. So to do this maybe a little bit faster way, let's see, we can't fit it all in there. Let's put it over here. We can enter this equation, 20 minus 18 over t, or x in this case, and then again, we can just graph this thing, and again, that's the equation, notice that there's 1, so that's kind of where that's why they're saying this only works after 1. Otherwise, it'd be a negative height of the tree, and that doesn't make much sense. So anyway, we can start plugging these numbers in here, right? So second calculate, we can just start plugging in a bunch of values. We want to know when x equals 2, and then that's going to be y equals 11, because that's 20 minus 9, right? So that's going to be, I'll write it up here, so that's going to be 11. Okay, and then the nice part about entering into the y equals, now we can just push 3, and it's going to change x into 3. That gives us 14. And then we'll enter in 5. That gives us 16.4. And then we enter in 10. And we're at 18.2. And then we enter in 50. So after 50 years. Uh-oh. I don't like that. Let's see. Let's go back to our graph. Let's see. So, let's see. We do calculate value 50. For some reason, it's not liking 50. Okay. So, we'll just do it by hand, I suppose. So we get 20 minus 18 over 50. All right. So 20 minus 18 divided by 50. All right, 19.64. So notice that it's growing pretty fast at the beginning. First year, it's at 2 meters. Then it's after 2 years, it's 11 meters, 14, and again, notice it's slowing down significantly here. All right. Anyway, find dh over dt, so the derivative of the height with respect to t. Okay, so basically just find the derivative of this function here. So we've got 20, the original function is 20 minus 18 over t. So that is the same thing as 20 minus 18, and again that's t to the first down here, move it to the top, turns into t to the negative first. Right, so now we take the derivative of that, and the derivative of the constant is 0. Negative 1 times negative 18 is 18 t to the negative second, or 18 over t squared. Again, either one is just fine. Okay, and it says what are the units for dh over dt? So that's with the height with respect to time. So the height is in meters, and the time is in years. So this is going to end up giving us our answer in meters per year. Okay, so that's C. Now, you'll notice here on D it says at what rate is the tree growing at t equals 1, 3, and 10 years. So now when we're talking about the rate of the growing tree, that's when we want to use our derivative. Okay, so really plugging stuff in is probably going to be a little bit nicer with 18 over t squared. So let's use that one. So we've got, for 1, we've got 18 over 1 squared, which just gives us 18. So when t equals 1, it's 18. It's growing at 18 meters per year. Oops. So it's growing pretty fast at the beginning. And then for the next one, we got 18 over, let's see, we've got 3 squared. So that's 18 over 9, which is just 2. So at 3 years, it's growing at 2 meters per year. So again, slowing down significantly. And then at 10, so we got 18 over 100. So 18 divided by 100 gives us, it's growing at 0.18 meters per year. So again, it's growing pretty slow. So it grows really fast at the beginning, and then it slows down pretty fast after that. Okay, so explain why the dh over dt has to be greater than 0 for all t greater than or equal to 1. Okay, so again, the derivative here is going to have to end up being greater than 0, well, one, because we're figuring out that this is a growing tree. The tree's not going to grow negatively, right? So again, this means that what does this mean in terms of the tree's growth? That means that it's always growing. Okay, and we also know that when you take any number, especially a positive number here, and you square it, you're going to end up with a positive number. So it's always going to have to be, this number here is always going to have to be greater than 0, because it's a positive divided by a positive, which will always give us some number greater than 0. It'll never give us a negative. All right, let's take a look at number 6. All right, total cost of running a train is given by this, where v is the average speed of the train in kilometers per hour. Okay, find the total cost of running the train at 20 kilometers an hour and 40 kilometers an hour. Okay, so again, it doesn't say anything about rate of change like it does down here in C. So that means we're just going to plug it straight into the original equation. Okay, so for A, let's see, this is really actually A, I. Let's make that look a little nicer. Okay, so A part I, we got 20 kilometers an hour, so that's really 200 times 20 plus 10,000 over 20. All right, so that's going to be what, 40,000, right? Because you got, no, just 4,000. There we go. So that's 200 times 20 gives us 4,000, and then 10,000 divided by 20, or 1,000 divided by 2 is 500 more. So that's going to give us 4,500 for A part I, and then A part II is going to be 200 times 40 plus 10,000 over 40, right? So 2 times 4 is 8, so this is going to be 8,000 plus 1,000 divided by 4 is 250, so that's going to give us 8,250, right? Okay, so the total cost is going to be, that's how much money it's going to cost to run the train at 20 kilometers an hour. All right, so part B, so we're showing that the derivative of the function, they want us to show that the derivative will equal this. So basically it's just find the derivative. All right, so here's our function. So let's just write it down here, 200 v plus 10,000 over v, right? So that's 200v. We got to move this v to the first up to the top, so plus 10,000 v to the negative first. Now we can take the derivative, right? So that's v to the first, so we just get 200 plus, actually negative 1 times positive 10,000 is minus 10,000, oops, I keep r, v to the negative second, right? Because we got to subtract 1 from that. Or we can write it as 200 minus 10,000 over v squared, which is what matches here. Okay. Now it says state the units of C primed that C primed is measured in. So the v, if you remember, the v up here is kilometers per hour. So this is really, and its cost, so really it's dollars over kilometers per hour. So we got to take that, we're dividing a fraction by a fraction, so we got to flip it and multiply. So that's the same thing really as dollars times, flip that over, h kilometers. So it's really dollars per hour, dollars and then dollars an hour per kilometer. That's weird. All right, we get that, and then there's, again, we showed that that's our derivative. All right, so C, find the rate of change. So again, rate of change, whenever you're talking about the rate of change, we know we're always going to take these things here, and to find the rate of change, plug it into the derivative. So here's our derivative. Okay, so CI, we're just going to plug that in. So we get 200 minus 10,000 over V squared is our formula. So we're going to put 10 in for that. So 10 squared. So it's 200. Let's see, that's going to be minus 10,000 over 10 squared is 100, right? So we get rid of 2 of those. So it's 200 minus 100, which gives us 100. So the rate of change and the cost at running the train at 10 kilometers an hour is $100 for every hours per kilometer. Weird. Okay. CII is going to be 200 minus 10,000 over 30 squared. So that's 200 minus 10,000 over 900. All right, so let's see what we get there. 200 minus 10,000 divided by 900 gives us 188.88. So 188.89 is our rate of change. All right, so there's number 6. Okay, let's take a look at number 7. All right, so here's a cross section of the sea, a hill, and a lake. Okay, and at the alongside is a land and sea profile where the x-axis is the sea level and the y-axis gives the height of the land or sea bed above or below sea level, and y equals this function here, kilometers. So find where the lake is located relative to the shoreline of the sea. So we want to know basically how far is it from here to here, right? We got to figure out what that is. So basically, since we know that the lake is right here at sea level, what we need to do for this is we need to take this equation here and we need to set y equal to 0 because the y has not gone up and down. It's right along the x-axis. So we'll do 0 equals 1/10 x times x minus 2 times x minus 3. Okay, so basically we got to figure out what makes each of these 3 pieces here equal to 0. So x has got to equal, so 1/10 of 0 would work. 2 minus 2 would give us 0, and so would 3 minus 3. So the 3 x-intercepts here are all, let's see, this one's at 0, this x-intercept here is at 2, and this x-intercept here is at 3. So that means that find where the lake is located relative to the shoreline of the sea. It's 2 kilometers inland, right? Okay. Show that y equals 1/10 of x cubed minus 5x squared plus 6x. So basically, we just got to multiply this thing out, right? So again, show basically means take us through the process on how you do that. So let's do x minus 2 times x minus 3. I'd like to do that part first and then multiply it all by 1/10 at the end. Negative 3 times negative 2 is 6. Negative 3 times x is negative 3x. That's positive 6. X times negative 2 is negative 2x. X times x is x squared. So we get x squared minus 5x plus 6. Okay? And then now we got to multiply that all by 1/10. The nice part is they left the 1/10 out there. So you know what? Let's make this correct here. So we would do. We want to take 1/10 x times this x squared minus 5x plus 6. Right? So again, they left the 1/10 out, which was nice. And then we're just going to distribute the x through. So x times x squared is x cubed. x times negative 5x is negative 5x squared, and x times 6 is plus 6x, and this matches that. Okay, so we've shown that. And then part C says find the derivative and interpret its value when x equals a half and when x equals 1.5. Okay, so here is our function. So we're just going to take the derivative of this. Now we have this 1/10 out front. We can just leave that 1/10 out and just take the derivative in here and leave this 1/10. So we can do 1/10, 3. The 3 comes out front here, so we got 3x, subtract 1, and that's x to the second. And then 2 times negative 5 is negative 10x to the first. And then 1 times 6 is 6, subtract 1, and that's all we have. So there's our derivative function, right? So now let's plug in the value when x equals 1/2. So we've got 1/10 of 3 times 1/2 squared minus 10 times 1/2 plus 6. Oh, that's fun. 1/10. Let's see, 1/2 times 1/2 is 1/4, so that's 3/4. Half of 10 is 5 plus 6, right? So we've got 1/10 of, let's see, we got negative 5 and 6, that's 1 3/4, right? So 1 3/4, so 1/10. Oops, kind of drew through the middle of that, sorry. Okay, so 1/10 times 1 3/4. Okay, let's try this. We got 1/10. I'm going to turn 1 3/4 into 1.75. So multiply that by a tenth, and we get 0.175. Okay, so it says find and interpret the value when x equals 1/2. So when we plug in a half, we get 0.175. So that means that 1/2 is somewhere on this side of the hill. So it's because it's still going up at some point. So we can, like, say, pretend that that's our there's our tangent line. So again, since it's positive, we know it's still going up. So it's it's before it gets to the top of the hill. Okay. Now if we plug in 1.5, let's see, I'm going to move this up here so we have some more room. All right, so we plug in 1.5 into this. Let's see, so we got 1/10 of 3 times, let's go with 1.5 squared minus 10 times 1.5 plus 6. Okay, let's just put it in our calculator to save ourselves some time here. So 1 divided by 10 times 3 times 1.5 squared minus 10 times 1.5 plus 6. Okay, and the calculator should do all the order operations nicely for us, and it gets us negative 0.225. Okay, so interpret the value there. That means since it's negative, there's our first one, since it's negative, that means it's now going down. So looking back at our picture here, we know that it's somewhere over here, right? So that means that the very top of the hill is between 1/2 and 1.5. All right? Okay. Got a couple more to take a look at here. We've got 9. It says the cost function for producing X items each day is this. Find the derivative and explain what it represents. Okay, so let's try that first. So A, the derivative of this. So that's another treat here to multiply all these fun things out. Okay, so we got 0.000072 times 3. gives us 2.16 e to the negative 4. So we're going to move that decimal over 1, 2, 3, 4. So it's 0.123214 x, and then again we got to subtract 1 from that, so it's x squared minus, and then that's 2 times this, so we've got 2 times 0.00061 gives us 0.00122. Okay, right, and then that again subtract 1 from the power there, and that gives us x to the first. Right, this is x to the first, so 1 times 0.19 is 0.19, and the derivative of the constant here is just 0. All right. Okay. So since we just took the derivative, we're finding the rate of change. Right. That's what the derivative of the function is. So it says explain what it represents. So this would represent the change in cost with respect to producing X items every day. Okay. So this is just the change in cost. Okay. B, find C prime of 300. So notice that the X now turns into 300. So now we want to plug 300 into this. So 0.000214 times 300 squared minus 0.00122 times 300 plus 0.19. Okay, so let's plug that again into our calculator. 0.0214 times 300 squared minus 0.00122 times 300 plus 0.19. All right, so we get 19.084. Oops, just realized that this over here is supposed to be 0.216x squared. Right, so if we change that, now again, I don't want to have to enter that whole thing back in, so I'm going to do second entry, and now I can just go back in and change my 4 to a 6, and it's actually supposed to be 19.264. Okay, so equals 19.264. Okay, so what this represents is the change in cost on how much this estimates how much it should cost to make the 301st item. Okay, so this is simply an estimate. Okay, and then of course part C is going to say find the actual cost of producing the 301st item. Okay, so let's enter that in. Okay, and I'm going to pause it here just for a second so I can put that all in so you don't have to wait for me. Okay, before I start entering that all into the calculator, let's talk about what we need to do. What we really need to do is we need to figure out how much it's going to cost to make 300, and then we need to subtract the cost of making 301, and that will tell us the difference between those two, how much it costs to produce the 301st item. Okay, so I'm going to enter those things in, and then we'll start back up. Okay, so here's the equation. I just plugged 300 in for all these x's here. Okay, so when we do that, we get 2839.1. So cost to make 300 is 2839.1. 2839. So it costs $2,839.10 to make 300. Now what we want to do is we want to figure out how much it costs to make 301. So again, I'm just going to do second entry, and I'm going to change all my 300s to 301s. Okay. And then we push enter there. So to make 301, it's 2858.43. 2858.43. So cost to make 301, is that. Sorry, that's supposed to be a $sign. That's pretty bad. So what we need to do is we need to figure out the difference between those two. So we just have to subtract those two from each other. Okay, so let's do that here. So we got our 28, 30, nope. Let's do the 2858.43 minus 2839.1. And that gives us $19.33 is about that's the more exact answer on how much it takes to produce the 301st item instead of just the 300. Okay, so again, we estimated it to be $19.26. It's actually $19.33. So that's pretty close. That's pretty good. Okay. All right. Last one is number 10. Okay. Profit made in selling X items given by this. Graph P of X using technology and determine sales levels which produce a profit. So let's put this thing here into the graphing calculator and graph this thing. So we got 5x minus 2,000 minus, and then we have x squared divided by 10,000. Okay, so again, the big key here is going to be our window. X is talking about the number of items that we're producing, so we obviously cannot produce negative items, so we'll do 0. Not really sure how many that we're going to produce. I'm just going to guess and go with 1,000. Okay, so we'll make our scale by 100. Again, this is really pretty much a guess. And then our Y minimum, we're hoping that we're not going to lose a bunch of money, so let's put our Y minimum at 0, and our maximum, who knows, let's try 5,000, give that a look and see what happens there. All right, it's just a shot in the dark, see what we get. Oh, there it goes, and it's just going up. So we're going to have to modify this here. Okay, so we're assuming here that this graph is probably going to go up. It's eventually going to max out and probably come back down. So we need to take a look further to the right over here. So let's change our X maximum. We're at 1,000. Let's do 10,000. See if that shows us anything better. Oh, okay, there it goes, zipping up here. Let's see if we see it come back down. Nope. So we've got to make our X max bigger. Let's go 50,000. That's a lot of items. And then our Y max, we need to make that, looks like that had to be pretty big too. So let's go, we're at 5,000. Let's go 25,000. Again, just kind of guessing here. Uh-oh, what did I do? Well, at least we got the X right, but our Y value, Y max, oh, I did 2,500. I want 25,000. Okay, it still has to go up a lot higher than that, so let's change that 25,000 to, I don't know, let's go 25,000 to say 60,000, see if that gets us to the top. Ooh, we're so close. Alright, I'm just going to change that to 70,000. That'll work. Alright, so that should get us the graph that we're looking for. Okay, good. We can see everything in there. So again, they're asking us, use technology and determine sales levels which produce a profit. So everything in here produces a profit. So really what we need to do is we just need to figure out what these two x-intercepts are at, right? So let's calculate the zeros. Okay, so left bound. Again, I'm just going to keep going over here to the left, and I'm going to be watching. I'm going to watch this Y value here. As soon as this Y value turns to negative, then I know I've gotten as far left as I need to. So let's just wait it out. Okay, getting close. There we go. Y is now negative. So I'm going to push enter, And then I'm over here. The y is now positive. So I push enter again, and it gives us that the x has got to be 403. Okay. So we've got 403. So using technology and graph this, use technology and determine sales levels which produce a profit. So x has got to be greater than 403, but then it's also going to have to be less than whatever this is over here. All right. So let's calculate that 0 as well. All right. That's going to take a while to get over there, but that's all right. Okay, I paused it and got it farther over there. Here it is. So again, we're still positive here, so we're okay. And then I just want to move this over until that y value here has turned back into a negative, which it has. Push enter again, and then that y value is, wow, 49,597, we'll call it. 49,597. 49,597. Okay, so that's the sales levels which produce a profit. Okay, find the derivative of the function and find x when the profit is increasing. All right, so let's find the derivative of this. So that's x to the first, so 1 times 5 is 5x to the, minus 1 is 0, so that's really just 5, right? Okay. Derivative of constant goes away, and then 2 times 1 over 10,000 turns into 1 over 5,000, and then that's 2 minus 1, so it's 1 over 5,000x. 5 minus 1 over 5,000x. Okay. Hence, find x when the profit is increasing. All right. So to find x when the profit is increasing, if we're using our derivative function here, basically what we want to do here is we want to set this, our derivative function here, x equal to 0, because as soon as, basically what we've got, if you remember what the graph looks like, is it looks like this here, right? So all the way, let's use a different color here, all the way from here all the way down to wherever it begins here, this is all the time, all the spots here where the profit's increasing. Now once we get past the maximum here, now the profit's decreasing. So basically we just have to figure out what is this maximum point here. So again, it would be a lot easier probably on the graphing calculator, but you know what, this really is not too bad. So let's just figure it out with just by solving this, right? So subtract 5 from both sides, and we get negative 1 over 5,000 x equals negative 5. So really we just need to multiply the whole thing by, well, really if we multiply it by negative 5,000, this side over here is just going to turn into x. So negative 5 times negative 5,000 is 25,000. Okay, so that means that the x value right here at the top is 25,000. And then we don't necessarily care about the y right now, but so it says hence find x when the profit is increasing. So our answer for that is going to be x has got to be less than 25,000. That's when our profit is increasing. All right? Okay, that is 19J. All right, be sure to ask any other questions you have in class. Thanks.